Hi, my name is Matt Duff, and today we're going to talk about how to compensate for thermocouple nonlinearity. So in the last session we learned that thermocouples have nonlinearity, but fortunately this nonlinearity is pretty constant for a given thermocouple type, and because thermocouples have been around for a long time, there have been folks that have done extensive characterization work on thermocouples and really figured out exactly what this nonlinearity is. And they've provided two different ways where you can figure out what the nonlinearity is. So if we go over here, one way that folks provide is by using an equation. So people have figured out that if I use an equation of this type where V is the voltage that the thermocouple is producing, if I put it in this equation with these certain constants, I can figure out what my temperature is. Another way that you may figure out what your nonlinearity is that folks also publish tables where the tables show that at a given temperature you'll have this much output voltage from the thermocouple. So you may get this information from your thermocouple manufacturer. If your thermocouple manufacturer doesn't provide it, a good place to get it is from the National Institute of Standards, also known as NIST. So if you Google NIST and thermocouples, you should be able to get to an extensive database where they have both tables and these equation types. Now the interesting thing about both these equations and these tables is that they are characterized assuming that the reference junction is at 0 degrees C. And of course, for your real life system, you don't have this reference junction is going to be something other than 0 degrees C. So you might think, okay, that's no big deal. What I'll do is I'll just use this lookup table or this equation and convert my voltage and then add my temperature sensor temperature that I got, and it will give me the right answer. And actually what happens is that gives you something close to the right answer, but because of the thermocouple nonlinearity, it's not going to give you actually exactly the right answer. So I'm going to give you the process that you use to actually get the exact right answer. So what you need to do is step one is you need to convert your temperature that you get from your temperature sensor into an equivalent thermocouple voltage. So I've called this temperature TTS for temperature sensor. And we're going to convert this into voltage TS, which is the equivalent thermocouple voltage from the temperature of your temperature sensor. So then the next thing you do is you take your measured thermocouple voltage, VTC, and you add it to your VTS. And then the third step is you take this total, so I guess we'll call this V total, and you convert that V total to a temperature. And that temperature is your final temperature that you're going to use for your system. So for both step 1 and step 3, you'll use these lookup tables or you'll use these equations. And the nice folks at NIST, for example, provide the equations both to go this direction and to go this direction. And this is how you do the conversion to account for both the cold junction and for the nonlinearity.